Pulling out from Marinaris, we can see the countryside round about. We can't see the spreading plates as easily here as we can in the Valles Marinaris itself. But NASA, using radar scanning devices, has mapped the tectonic heights and depths of Mars' surface. By assigning colors to the various heights, a clearer picture emerges. Lower land is blue, then up to green, then yellow, orange, then red and magenta. Finally, a pinkish gray. Here, yes. I don't know about you, but I think this is fantastic. It's the Grateful Dead version of Mars. By separating the levels with colors, we are almost invited to slide these layers of plates together. As you know, these indeed are plates, that is, layers, like slate, like a cake, capable of being slid or moved apart and over each other when under strong pressure. If we move these layers back together, will the levels be assembled with each other? Let's slide these levels together and see if the colors reassemble on their levels. A warning, this couldn't happen unless Mars grew. Let's go forward in time. Now a comparison. The lower tectonic plate, the blue plate, begins back in time hidden, only to be revealed as a new lower plate. With, as you can see, no new craters. Am I tricking you and finagling with this map? Nope. You can see it clearly. You can see what we're doing frame by frame. Let's do the whole planet next. As we pull out to view the full planet, I'd like to prepare you for our next demonstration. As I implied before, science can identify older, higher tectonic plates or areas on, in this case, Mars. The upper plates are darker in color to begin with. Sometimes they're not. Then they, the older surfaces, have a great many more impact craters, which take time to accumulate. The lower, newer plates, conversely, have way fewer impact craters, and they are conveniently lighter in color for the most part. More recently, scientists have identified with radar scanning equipment those areas which are upper tectonic or higher elevated and older areas, and those areas which are lower tectonically. The darker areas are nearly always higher. The lightest, however, are always lower. The big tip-off is more time makes more time for meteors to crash into Mars. The newer the surface, the less time for meteor hits. We call this area the T-shirt. It is also called Acidala Planitia. I hate these Latin names. Check out the craters. Uniquely, though dark, some spreading has taken place, smoothing out some cratering. However, over here in this area we call the Tombstone, it's extremely heavily cratered and dark mineral deposits coated. This is clearly upper tectonic land. Think of it as a continent. This land up here is lower tectonically, younger, identified by scientists as younger. There's a piece of broken away upper tectonic plate in the middle of this lower tectonic plate. Do you see the old impact craters? Do you see how few impact craters there are up here? Above this, closer to the North Pole, the land is clearly and obviously thicker again, and heavily cratered. Come look over here past the T-shirt. Look at this fantastic lowland spread. Big and so far spread, and it's more medium in tone. It's youngish, but aging. Down in this southern area, we have a vast expanse of upper tectonic plate. The color is medium to dark, and impact craters are abundant and pervasive. It's like an orange outgrew its skin, and so the skin broke to let the orange expand. In Mars's case, most of the skin remained at the southern hemisphere. On Earth, most of the skin remained on the northern hemisphere. Mars relates to Earth, but upside down. There's the Tombstone up there, remember? This is a very, very new spread, way low tectonically and very light in color and practically unmarked by craterization. As we go up north, observe these stretch areas. We will soon unstretch them in our example. Now we're in a vast stretch area, which connects with the area we saw on the other side. Here's a curiosity. A piece of upper tectonic land, actually a few pieces, stranded in the middle of this vast spread area like an island stranded in the ocean. Of course, we will try to find their original connecting tectonic coasts. Now we will watch Mars, the whole planet, go back in time. I'm going to ask Zia to provide a dotted line so that you can keep track of the start size. The upper tectonic plates move together as the planet gets smaller. This cannot happen unless the planet began smaller and got bigger. We are now a few hundred million years ago. Let's go back hundreds of millions of years further. I cannot say that all these movements are exactly right. They are the very best I can provide, working along a very strict set of guidelines. All the upper dark plates remain at the exact same size throughout. They don't stretch, squish, they don't rotate as if floating. Plates shift with growth. All portions follow sensible rules of cause and effect movement. These are tectonic movements, and within the tectonic movements there is no subduction. Tectonic movement without subduction. And bam, we've closed the upper plate. Mars is less than 50% smaller than it was, and about 1/4 the volume. To make its size more clear, here is our moon for a size comparison. In fact, at this size, if we take the reddish cast away, Mars kind of looks like our moon. We're going to go forward in time to reveal the lower tectonic plates. While the planet Mars grows, note that none of the dark tectonic plates change in size. They slide apart. You ever take a hunk of slate and wrap it to separate the levels? That's what happens when plates shift, and that's how we get earthquakes. Mars has become as familiar to us as the planet Earth is to you, so we can understand that you might have some confusion. Therefore, so that you can examine it closely, we'll hold on the two hemispheres. Please watch it carefully. Please notice plates don't move around a planet from one hemisphere to another or travel. The plates stay where they are. Only the planet grows. The question that must be asked is, how else does one explain the different ages of Mars's surface? This solution works, and in fact it's the truth. Mars grows.